Welcome back, guys. Now in this video we have to discuss some problems or some examples for finding oxidation state. Okay, we already discussed the rules for finding oxidation state. Based on that we can do some problems. Okay, then we can discuss some exceptional oxidation states. Before that, normal trending oxidation state we have to discuss, or we want to discuss. Okay, so let me show some examples. Ready? So in each molecule you're asked to find the oxidation state of some elements. Okay, and the underlined elements are simply the elements which you have to find the oxidation state. Ready? Okay, let's start. K2SO4. Okay, you are familiar with the two methods, either by putting unknown the oxidation state as X and or by a splitting method. So whatever it may be, put the oxidation state of X as sulfur as X. Okay, then +1 potassium into 2 plus X into 1 plus -2 into 4, which is equal to 0, right? That means 2 plus X minus 8 equal to 0. That means X is equal to +6. Or by a splitting logic, your potassium have to offer +2, oxygen has to offer -2. Okay, so the net excess charge is -6, so your sulfur should make up it by +6. Okay, the next is Na2CrO4 and chromium is the element. Ready? So sodium +1 into 2 plus the unknown chromium, let it be X, into 1 plus -2 into 4, the very same trend as that is in K2SO4. So it is 2 plus X minus 8 equal to 0. So X is equal to +6. Okay, or in a splitting logic, this offer +2 and this offer -2, right? So the excess charge is -6, and that should be given by your, that should be balanced by your chromium. So chromium having or chromium existing +6 oxidation state. Ready? Next, NaIO4, sodium periodate. Fine. +1 the sodium into 1 plus X iodine into 1 plus -2 into 4, that is equal to 8. So 1 plus X minus 8 equal to 0, which implies that X is equal to +7. X is equal to +7. Okay. Or by splitting this into 2, this offer +1 sodium, this offer -8. So the excess charge is -7, and the -7 charge should be made up by iodine. So iodine should offer +7. Is it okay? Fine. Next, KClO3. So potassium 1 into 1 plus the chlorine X into 1 plus -2 into 3, and the answer is equal to 0. So 1 plus X minus 6 is equal to 0. So X is equal to +5. X is equal to +5. Or by splitting, 3 oxygen -6, 1 potassium +1. So the excess charge is -5, and that is offered by your chlorine as +5. Ready? And you should know that ammonium dichromate, and you should know that the whole charge of ammonium ion is +1. Whole charge of NH4 is +1, because in NH4 there is a -3 from nitrogen and +4 from hydrogen. So the whole excess charge will be a +1 charge. Okay, that you have to know. Then only you can do this. Okay. So you treat your NH4 plus as a single entity, or the whole charge of NH4 is +1. So this is something like a +1 charge. So +1 into 2 plus the next chromium X into 2 plus -2 into 7, which is equal to 0. Fine. So 2 plus 2x minus 14 equal to 0. So 2x is equal to 12, x is equal to plus 6. Okay, ready? Or it can be find by splitting. So via splitting, this ammonium plus 1, so 2 ammonium plus 2. Oxygen minus 2, so 7 oxygen minus 14. So the excess charge is minus 12 and it should offered by your chromium. So chromium for offer plus 2, plus 12, but there is 2 chromium. So each chromium offer plus 6. Okay. The next is sodium peroxide, Na2O2. Sodium peroxide. Well, the underlined element is oxygen. It's not sodium. Okay, oxygen. Fine. So you're asked to find the oxygen state of oxygen. So it is not equal to 2. It may be any number other than 2. Minus 2 is the common oxygen state of oxygen, if you know that. And here you are asked to find the oxygen state of oxygen. So it won't be minus 2. It may be any other value. Okay, anyway, the sodium plus 1 into, it's not x, into 1 plus into 2, plus 1 into 2 plus oxygen, we don't know oxygen state of oxygen. Let it be x into 2, which is equal to 0. So 2 plus 2x is equal to 0. So x is equal to minus 1, right? X is equal to minus 1. Or by splitting, we know this part can offer plus 2. So compulsory, this should offer minus 2. So 2 oxygen offer minus 2. So our oxygen have minus 1. Okay. Is it okay? Ready. Move to the next. Your next component is HClO4. 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 Ready. Let in HClO4, your chlorine be X, unknown X. So hydrogen plus 1 into 1 plus the unknown X into 1 plus minus 2 into 4, which is equal to, which means plus 1 plus x minus 8 equal to 0. So x is equal to minus 7. X is equal to, x is equal to plus 7. Or by splitting this into 2, this part of a plus 1 and this of a minus 8. So the excess charge is minus 7 and the excess minus 7 is offered by or balanced or make up by your chlorine. So chlorine should offer plus 7. The next is Mn2O3. Okay, let Mn be the unknown. So x into 2 plus minus 2 into 3, which is equal to 0. So 2x minus 6 is equal to 0. So 2x is equal to plus 6, which means x is equal to plus 3. Okay. Or by splitting it into 2, this offer minus 6. So this should offer plus 6. And that plus 6 is from 2 manganese. So 2 manganese is equal to plus 6. So each manganese is equal to plus 3, right? Fine. The next is Fe2SO4. Thrice. I already told you that SO4, the species having a whole charge of minus 2. Okay. So here we are asked to find the oxidation state of iron. So let iron be x into 2 plus SO4, the charge is minus 2 into 3, which is equal to 0. So 2x minus 6 is equal to 0. So x is equal to once again plus 3. Plus 3. Or by splitting idea, let split it into 2. This will minus 6 because 3SO4 will be in a minus 6 oxidation state. Okay. So this part should offer plus 6. So 2 iron in a plus 6. So iron in a plus 3. Okay. Iron in a plus 3. Ready. The next is Cu2O. You're asked to find the oxidation state of copper. Let it be X. So X into 2 plus oxidation minus 2 into 1, which is equal to 0. So 2x minus 2 equal to 0. So x is equal to plus 1. Okay. Or by splitting into 2. Splitting into 2. Here minus 2. So this should be plus 2. But that plus 2 from 2 copper. So a copper should offer a plus 1. Okay. You can use any one of this method. Okay, you can use any one of this method. Which is more comfortable for you, that you can use. Okay. But we are dealing with objective questions, so you have to do it in as much as possible or in a speed which is as far as possible. Okay. So do it fast. Okay. You can use any kind of method. Ready? Okay. So let the oxidation state be x into 1 plus minus 2 into 2, which is equal to minus 3. So x minus 4 equal to minus 3. So x is equal to plus 1. X is equal to plus 1. Or we can split this into 2. Here minus 4. Inside minus 4. Outside is minus 3. So this minus 4 and minus 3 cancelled. So the net excess is minus 1. And that minus 1 should offered or balanced by phosphorus as plus 1. Okay. Ready. The next species is IF4 plus. IF4 plus. Okay. Let this be the atom that we have to find the oxidation state. X into 1 plus minus 1 into 4, which is equal to plus 1. So x minus 4 is equal to plus 1 and x is equal to plus 5. Okay. Or by in a splitting logic, for fluorine minus 4. Okay. Listen, here already minus 4, but we want plus 1 outside. So if this is plus 4, what happens? Here already inside there is already minus 4 and we need plus 1 outside. If here is minus 4, if the iodine is in plus 4, what happens? The outside will be 0, right? Yeah. If iodine is in plus 3, what happens? The outside will be minus 1. So it is very easy. In order to get plus 1 outside, if minus 4 is in here, then the charge of iodine will be plus 5. It's a simple mathematical idea. Move to this one. X into 1 plus minus 2 into 3, which is equal to minus 2. So x minus 6 is equal to minus 2, x is equal to plus 4. Or by splitting, here minus 6 and outside minus 2. So simply cut it. So the net is minus 4 and minus 4 offered by or balanced by sulfur. So sulfur should offer plus 4. Okay. What about here? Carbon x into 2 plus minus 2 into 4, which is equal to minus 2. So 2x minus 8 is equal to minus 2. So 2x is equal to plus 6, x is equal to plus 3. Okay. Or by splitting it into 2, here minus 8, outside is minus 2. So this is cancelled minus 6. So the excess charge is minus 6 and it offered by carbon. So 2 carbon should offer plus 6. So each carbon will be plus 3. Okay. The next molecule is BrO3 minus. BrO3 minus. Okay. BrO3 minus. Let the oxidation state of bromine is x. So x into 1 plus minus 3 into 2, all of minus 1. So x minus 6 is equal to minus 1. So x is equal to plus 5. Or by splitting it into 2, here minus 6 and outside is minus 1. So this is cancelled. The next charge is minus 5 here. So bromine should offer plus 5. Okay, in all sense the answer is same. So you can use any one of this method. Okay, which is more comfortable and which require less time, that you have to choose, because we are dealing with the objective question. So this is a usual method or a usual examples. Let me discuss exceptional oxidation state. Exceptional oxidation state of some compounds or elements in some compounds. That's the most crucial one. Okay. Okay. So moving to the next section, exceptional oxidation state. Okay. Exceptional oxidation state. Listen, these all are important. Your first molecule is perchromic acid. Perchromic acid. CrO5. CrO5. Perchromic acid. In a normal view, this is x into 1 plus minus 2 into 5, which is equal to 0. That is, x is equal to plus 10. In a normal sense, the oxidation state of chromium is plus 10. But this is known as pseudo oxidation state. This is known as pseudo oxidation state. What do you mean by pseudo oxidation state? Pseudo oxidation state means oxidation state of element greater than oxidation state of element greater than limit. The oxidation state which exceeds the limit of that element. Okay, that is said to be pseudo oxidation state. We know that the maximum oxidation state shown by osmium and ruthenium. The maximum oxidation state given by an element is +8, and it is shown only by your osmium and ruthenium. Okay, and the maximum limit of chromium is +6, but here it is +10. So this kind of oxidation state is said to be pseudo oxidation state. So pseudo oxidation state means oxidation state which exceeds the limit. Okay, so this kind of pseudo oxidation state not valid. Not valid. Okay, so let's check what is the actual oxidation state of chromium. The actual oxidation state of chromium is +6. Okay, so you have to know that it is +6. Ready? Okay, and how it become +6 means it have a special structure, a butterfly like structure, like this, with the 2 peroxide linkage. A butterfly like structure with the 2 peroxide linkage, and this structure is known as butterfly structure. Okay, there is 2 peroxide linkage. Okay, the peroxide linkage are peroxide linkage number 1, linkage number 2. This is in -1, this is also in -1. -1, -1. We know that the polarization of peroxide linkage is -1, -1. So this of a -1, -1, -1, -1. What about this one? Electronegativity towards oxygen. So a -2. So surrounding to chromium, there is a total of -6 charge. So chromium should balance it by +6. So the actual oxidation state of chromium in perchromic acid is +6. It is not +10. +10 is a pseudo one. It's not valid. So you have to know that the oxidation state of chromium in perchromic acid is +6. Okay. Move to the next category. K3CrO8. K3CrO8 or CrO8 3-. This is a special compound, just like your CrO5. Okay. What about this oxidation state? +1 into 3 plus x into 1 plus -2 into 8, which is equal to 0. So x becomes +13. +13 means it is pseudo oxidation state. So this is not valid. So the actual oxidation state of chromium is +5. It's not +13. It is only +5. Then how it become like that? That then you have to know the structure of chromium. Here there is 4 peroxide linkage. 4 peroxide linkage. Okay. And this is K3CrO8. And the polarization -1, -1, -1, -1, -1, -1, -1, -1, -1. So around chromium, there is actually -8 charge. Okay, so it will be balanced by it will be balanced by it will be balanced by a +8 charge, where the for +8, +3 is already offered by a potassium, so chromium should offer +5. So the total negative charge is -8. So there we have to find a +8 charge. For potassium, the cation offers +3. So chromium, the excess, +5 you have to offer. Okay. So you want to offer the +5. So the oxidation state of chromium is +5 here. Ready? If these 3 potassium is removed, it will be CrO8 3-. Both have same structure like this. Okay. This is another kind of your exception. Ready? Moving to some more examples. The next example is Carose acid. Carose acid. We know the structure of sulfuric acid, right? We know the structure of sulfuric acid. S double bond O, OH, OH. This is the structure of sulfuric acid. Agreed. It is already discussed. Okay. Now the next category is Carose acid. Carose acid is said to be peroxy monosulfuric acid. Peroxy monosulfuric acid. That is said to be Carose acid. Peroxy monosulfuric acid. Okay. And formula will be H2SO5. H2SO5. Ready? So what about the oxidation state of sulfur? In a normal sense, +1 into 2 plus X plus 5 into -2. So normal sense it is +8. Okay. So +8 is also a pseudo oxidation state, because the maximum limit of sulfur is +6. Because sulfur is in a +16th group, right? Yeah. So the actual oxidation state of sulfur here is +6. What? +6. Then what is the difference? This is not H2SO4. This is H2SO5. So what about H2SO4? H2SO4 is something like this, right? Yeah. Okay, there is one more oxygen. So that oxygen exists in like this. And this is a structure of, it's not a structure is a tetrahedral structure. This is the arrangement of your Carose acid. So this offer -2, this offer -1, this offer -2. And I already told you that in the case of OH and OOH, the net charge, in the case of OH, oxygen offer -2 and hydrogen offer +1. So the net charge of this bond is -1. In the case of OOH, these two oxygen offer -1 and this hydrogen offer -1. So the net charge is the very same -1. So both OH and OH have same kind of charge, -1. So around sulfur, there is actually -1, -2, -2, -1. That means -6 charge is there. So sulfur should have to offer +6. Okay, ready. And this is a special example. And your Carose acid, H2SO5, on hydrolysis, forms H2SO4 plus water. Sorry, H2O2. H2SO4 plus H2O2. So kerosene acid on hydrolysis forms H2SO4 plus H2O2. How it become like that? Your kerosene acid, and it is this reaction will be discussed in the preparation of sulfuric acid. Sorry, hydrogen peroxide in chapter number 9, hydrogen. Okay. How the hydrolysis proceeding? On adding water, this bond cleaved, and here the H, and here will be the OH. So this one will be sulfuric acid, like that, and this one will be the hydrogen peroxide. Okay. Exactly in the same fashion, we can discuss Marshall's acid also. Marshall's acid, and it is known as peroxo disulfuric acid. Disulfuric acid, and the formula will be H2S2O8. H2S2O8. And what about the oxidation state in a normal sense? +1 into 2 from hydrogen part, plus X into 2 from sulfur part, then -2 into 8 from oxygen part. So 2 plus 2x minus 16 equal to 0. So X is equal to +7. But that +1 is also pseudo because it will not exceed +6, because +6 is the limit of sulfur. Okay. Now, the actual oxidation state. The actual oxidation state here is +6 again. Ready? Okay, now it become +6, or how it become peroxo disulfuric acid? S double bond O, double bond O. This is one sulfuric acid. This is another sulfuric acid, right? And these two sulfuric acids connected by a peroxide linkage. So this is a peroxo disulfuric acid. Peroxo disulfuric acid. Ready? What about the oxidation states? Bond to here -2, to here -1, to here -2, to the -1. The very same here also. Electronegativity to the -1, to here -2, here -2, to here -1, right? Yeah. Tell me, the charge around sulfur, -1, -2, -1, -2, -6. So sulfur have to offer +6. Around this sulfur also, -1, -2, -1, -2, -6. So sulfur have to offer +6. Okay. And this Marshall's acid, H2S2O8, on hydrolysis using 2 mole of water, it become 2 mole sulfuric acid plus H2O2. And from the structure, it is clear that how it become like that. Listen. H double bond O, double bond O, OH. O, O, S double bond O, double bond O, OH. Right. And the hydrolysis will be like this. Listen. Cleft OH, H. Cleft OH, H. This become hydrogen peroxide, and this becomes sulfuric acid. This also sulfuric acid. So 2 mole of sulfuric acid. Okay. Move to the next cases. And there is one more type of exceptional oxidation state, what we called as paradox oxidation state. Let's check.